Section 3.2 deals with what's called synthetic division. This is going to be a way to do division with polynomials. The division algorithm, which technically you've learned this in its numerical form back in, I'd say probably second or third grade, but you haven't seen it written like this. F of x is my dividend. I'm going to bring back some old terms here that you may not have heard for a while. G of x is my divisor. Q of x is my quotient. Terribly written, but that's my quotient. And R of x is my remainder. So what is this? This is basically what you learned a long time ago. It was how you checked your division problem. So let's say way back, again, I don't know, second, third grade, something like that. If I had 27 divided by 4, okay, and so I'd go, all right, that goes in there 6 times. 6 times 4 is 24. The old way you used to write this would be remainder 3. But then you would check it technically with the division algorithm, which says the dividend, which is the 27, should equal the divisor 4 times the quotient 6 plus the remainder 3, which that does work out. The little note here says if R of x is 0, that means both the divisor and the quotient are factors. So if, for example, this was, let's say 4 divided by 24, you would have said, okay, it goes in there 6 times. No remainder, or a remainder of 0. That tells me that 4 is a factor of 24, and 6 is also a factor of 24. That's all this stuff is saying. It's just saying it in polynomial type form, more of an algebra way of saying it. What we're going to deal with is synthetic division. And in synthetic division, our divisor is always going to be a linear divisor. Basically, it's going to be an x to the first. Same rules are going to apply. All of this is the same, except we're going to deal with, again, a linear divisor, only x to the first power. So how do we do synthetic division? Well, notice that it says x minus k. The k number is what I'm going to be using. So if this is x plus 2, I have to switch its sign to a -2. So this is going to be -2, and here's how I draw this up. Now, different teachers can sometimes draw this slightly differently, but I'm going to put -2 in a little half of a box. I'm going to then take my coefficients, 5, 6, 28, and the constant 2. Well, some of those were negative, sorry. And I'm going to list those next to it. So I've got 5, -6, -28, -2. Leave a little space, put a bar, and I'm going to put a little part of a box down here. This little box on the right, on the bottom right, that's where my remainder is going to be. Basically, what's going to happen is dividing each term up here by a linear factor is going to drop the powers by 1. So it started with an x to the third. That's going to drop to an x squared. The x squared is going to drop to an x to the first, and so on and so forth. So how do I actually do this? I'm going to drop down the first number. That doesn't change. And now what I have to do is multiply the -2 by that number. So -2 times 5 is -10. That's going to go here. Now I'm going to add these two together. -6 and -10 is -16. Repeat the process. Multiply the -2 times the -16. That's 32. Add these two together. That's going to give me 4. Repeat the process. -2 times 4, -8. Add these two together. That's going to give me -10. Okay, so I've dealt with the numbers. Now I just need to throw the variables back in. As I said, it's going to decrease by 1 power. So it was x to the third. That's going to turn into x squared. So it's 5x squared minus 16x positive 4. That has no x's on it. Now I do have a remainder here. Think about how you did remainders after you did the R stuff. So if I took this back to that 27, and that gave me a remainder of 3. After we stopped doing R3, we started putting the remainder over the divisor. So I would say 3/4. Same thing's going to happen here. I'm going to take the remainder -10 and put it over the divisor. Now remember, the divisor was actually x plus 2. So that's my quotient. There's my answer to the problem. So since I did not get a remainder of 0, that tells me that x plus 2 is not a factor of 5x cubed minus 6x squared, all that stuff. Now, there are some tricks to this you've got to be aware of. So the first thing is to remember that I have to switch the sign. So that's x plus 1, so I have to turn that into a -1. Now, I always want my dividend in decreasing powers, which it is in decreasing powers, but this didn't come up on the first problem. Notice I got x to the 4th, x to the 3rd, x squared. There's no x to the 1st. To be able to properly do this and keep everything spaced correctly, I have to put in a 0 there as kind of a placeholder. So this is going to be -11, -2, -8, 0, because that covers the x to the 1st power, -4. You remember when you used to do long division as a kid, everything had to be lined up properly in the columns, otherwise you'd mess it up. Same thing here. Okay, so now, again, I start off by just dropping the first number. Now it's multiply, so -1 times -11 is 11. Add these together. That's going to give me 9. Keep repeating the process. -1 times 9, -9. Add these together. That's going to give me -17. -1 times -17 is 17. Add these together. +17. Repeat. -1 times times 17 is going to give me -17. Add these together. -21 is my remainder. And again, since I did not get a remainder of 0, that will tell me that x plus 1 is not a factor of the -11x to the 4th stuff. Okay, so I did the hard part. Don't forget to add the x's back in there. Remember, the powers will drop by 1, so this is -11 x to the 3rd plus 9x squared minus 17x plus 17, oops, not 12, 17. Come on, there we go. And then remember my remainder, negative 21, goes over my divisor, which was x plus 1. So there's my answer. For letter C, it's x minus 6, so that means a positive 6 is going to go in the box. Really switching that sign is accounting for in long division where I always subtract when I'm doing long division. So by switching the sign at the beginning, I'm covering that. Now this one, be careful, remember placeholders. I've got 3, but I don't have x to the second or x to the first on this one. So the first one has a coefficient of 1, but then there is no x squared, so 0. There is no x to the first, 0. Then negative 216. All right, repeat the process. Drop down the first one. 1, multiply. 0 plus 6 is 6. Multiply. 6 times 6, 36. 36. Don't need that right now. 6 times 36 actually is 216. Hey, looky there, I got 0. Weird looking 0, but I got a 0. That tells me that x minus 6 is a factor of x cubed minus 216. This is going to become more important as we roll through this rest of this chapter, so that's why I'm emphasizing that. Okay, so what did I end up with? Remember, the power will drop by 1, so I have 1 x to the second plus 6x plus 36. There is no remainder, so that's my answer. The next thing we're going to talk about is what's called the remainder theorem. If I divide some function by, and again, notice this is linear again, x minus k, it turns out that the remainder is actually just equal to if I were to plug in k into the function. So this is actually going to give us a fast way of knowing if something is a factor. So if k is 2, I'm going to throw 2 in for x. This would be 2 times 2 squared minus 3 times 2 minus 3. So if I run that, that's going to give me 8 minus 6 minus 3, negative 1. So that tells me that if I did synthetic division, my remainder would have been negative 1, which would have told me that, be careful, if k is 2, x minus 2 is not a factor of 2x squared minus 3x minus 3. For letter B, now I'm throwing something in there that's got some i's. Our friends, the imaginaries, are going to come back in this chapter. I'm going to plug in 2 plus I for every x. So this is going to be 2 plus I squared minus 5, 2 plus I plus 1. So 2 plus I squared, that's the real difficult part of this. I have to FOIL that out. So 2 times 2, 4. 2i, another 2i. Then careful, this would be plus I squared. But if you recall, I squared is negative 1, so it's actually minus 1. So what I actually get out of this is 3 plus 4i. Okay, for this next part, I'm distributing a negative 5 through. That's going to be minus 10 minus 5i. And And there's still that plus 1. And so if I put together the reals and the imaginaries, I end up with -6 minus I. So that would have been my remainder if I had divided x minus, let's rewrite that. If I had divided x minus the quantity 2 plus I into there. Now, we're not going to do synthetic division with i's, but i's will show up in some of the problems. This tells me, again, that this is not a factor because I did not get a remainder of 0. For letter C, I'm plugging in I root 5 for x. This would be 2 I root 5 squared plus 10. Okay, what exactly do I do with that? Well, I squared is -1. So I know that's just going to make that negative. Root 5 squared is just 5. So I end up with -10 plus 10, which is 0. And again, what does that also tell me? That tells me that x minus I root 5 actually is a factor of 2x squared plus 10. So that is what the factor theorem is telling me. The remainder theorem is kind of a building block that gets me to the factor theorem. So a function has a factor, x minus that k. This is not misspelled. This is if and only if f of k equals 0. So basically just what we were talking about. So decide if k is a 0. So again, I'm going to plug 2 into this function. So 2 cubed minus 3 times 2 squared plus 4 times 2 minus 4. Remember PEMDAS, do your squaring first, then you're multiplying and all that. You will end up getting 8 minus 12 plus 8 minus 4. And that is 0. So what does that mean? That means that 2 is a 0. 0 means it makes it equal 0. We just figured that out. Of f of x. But it also means that the factor x minus 2 is a factor of f of x. We learned two things out of that. These are basically synonymous. Being a 0 and x minus that number being a factor are the same thing. For letter B, unfortunately, I've got to throw in a weird complex number with an I in there. So this would be 2 minus I squared minus 4 times 2 minus I plus 5. If you square the 2 minus I off to the side, you'll end up with, let's see, you'll end up with 4 minus 2i, 2, minus another 2i, and then plus an I squared, which is minus 1. Then if you distribute the -4 through this, we're going to end up with -8 plus 4i. And then we still have a plus 5 at the end. So looking at my real numbers, I've got 4 minus 1, so 3, minus 8, -5, plus 5, 0. So those all zeroed out. If I look at my imaginaries, minus 2i, minus 4i now, plus 4i. Hey, looky there, everything's zeroed out. So what does that tell me? That tells me that 2 minus I is a 0 of f of x, and x minus the quantity 2 minus I is a factor of f of x. Again, those are synonymous. For the last couple problems here, we're going back to basically our division algorithm, what we started off with this. So we want to write this in the form divisor, quotient, plus remainder. So for k equals -1. So what does this mean? I want to go back to that synthetic division stuff. Now be careful. If I plug in, and people mess up this negative sign all the time, so you got to be careful. If I plug in a -1 there, it's x plus 1 actually. But remember, we switched the sign to do the synthetic division, which is going to take me right back to the -1. If I look, I've got x to the 4th, 3rd, 2nd. I don't have an x to the 1st, so I'm going to need a 0 placeholder. It's going to be 3, again, 3, 4, -10, 0, 15. So I drop down the first number, multiply the -1 times the 3, then I add. Multiply, add. Multiply, and add. And one more time, multiply, and add. So this is saying that I can write f of x as x minus k, which in this problem is x plus 1, times the quotient part. Remember, this is just going to drop by a power. So that's all this stuff. That's going to be 3x to the 3rd plus x squared minus 11x plus 11. And then it just wants it written not as a fraction, but just plus r. And again, my remainder was 4, so plus 4. Basically what this is saying is, hey, you could check your answers. It's kind of nasty, but you can multiply all that together, put everything together that you can, and then add a 4 on the end. You should get right back to what you started with. Again, it's how you check division way back in grade school. For number 5, k is 2. So again, realize that means that I'm dividing by technically x minus 2. But again, when I go to synthetic division, I switch the sign, which takes it right back to 2. This one does not need any placeholders because the powers go 3, 2, 1, none. So I'm just going to take the coefficients, -1, 1, 3, and the constant -2. Drop down the first number. Now it's multiply and add. Multiply and add. Multiply and add. So f of x can be written as x minus 2. And then the quotient, which again, if I add the variables back in, it's going to drop by 1 power. So it's going to be -x squared minus x plus 1. The remainder is 0. I don't have to write it, but just so I see that I did it the way the other one did, I'll put a +0 on it. And there we go.